What's up, math fans? So in geometry, first week of school, you learned something called undefined terms, and I did a video on that. Basically, point, then you turn into line, then you turn into plane, then we start talking about line segments and rays and stuff like that. So today, I'm going to tell you what rays do. Let's say this is a ray, and I'm not going to move this ray. Here's the end point, and it extends in this direction. Here's another ray. I'm going to join the endpoints, call it a vertex. Once I connect two rays, I got myself an angle. This is approximately a right angle. Here's a 0-degree angle, etc. Notice, I'm not going to move this ray. It's never going to move. Only this ray moves. Initial side, terminal side. So the terminal side, I can put anywhere I want, and I've created an angle. I'm going to start at 0. Now, if I do this, you can kind of see that I went all the way around and I created a, what is that when you turn all the way around? 360-degree angle, okay? But if I just showed it to you like this, how would you know if it's 0 or 360? So you would have to actually know what you're looking at, meaning they would have to show you a little loop here that shows we went all the way around, now we're talking 360. If you don't see a loop and you just see it closed, 0. Another famous one is 90. Another famous one is like this, which is 180 degrees. Here's some more vocabulary if you want to write this down. If they ask you to identify an angle that is less than 90 degrees, this is, you're so small, you're so cute. It's acute. This is an acute angle. Once I hit 90, it's called a right angle. Once you open it past the right angle, now we're going obtuse. This is an obtuse angle. I hit it straight line. Guess what else it's called? That's right, straight angle. Now if I continue going in this direction, like that, this is reflex angle. It's not that popular. Nobody really talks about reflex angles. It's like the stepchild of the angles family. And then of course all the way around is 360. Okay, so you got acute, right, obtuse, reflex, and straight angle. We're going to talk about in a second. So check out this diagram, and this diagram, and there's 3 separate things that you need to know about them. All right. So when you're looking at this, think about 3 different categories, 3 different types of equations that you're going to make. Notice I'm going to equations now because I feel like algebra is still kind of fresh in your mind. So I want to link geometry and algebra together. Some geometry teachers are going a different direction. Stay with the shapes, and we'll get to that a little later. Okay, so look at this big shape here, this big angle here. That is what kind of angle? I just said it, 90 degrees or right angle. So when you think about the relationship now I'm talking about angle relationships. What is the relationship between angle A and B? Well, they're next to each other, so they're adjacent. Adjacent means next to. And they're complementary. What does complementary mean? It's 2 angles that have a sum of 90 degrees. It's a hard word to remember. Think about, if I go like this, boom, there. Does that help you remember 90 degrees? See this 90 right here? You're welcome. Okay, so complementary, not as in I'm giving you compliments, but that we go together. Complementary means 2 things that go together, like this tie and this shirt. I like to think complementary, maybe not. Okay, so what is the relationship between A and B? They're adjacent, they're complementary, which means their sum is 90 degrees. So when you create an equation, and you might be asked to create your own equation, A plus B equals 90. Simple as that. And I'll give you an example if you stick around. Here we go. What's the relationship between A and B here? Well, they form together, they form a straight line. They're next to each other, and they form a straight line. So they add up to 180 degrees. They're supplementary. It's a little harder to see this one. Boom, boom, boom. You can always play that back in slow motion. 180. So the complementary means the sum is 90. Supplementary means the sum is 180. Try to make an equation like I did. How would you make an equation with A and B? A plus B equals 180. So remember the different categories. Depending on what you're looking at, that's your equation. It's not always the same. Here, A, B, they're not adjacent. They're not next to each other. But check this out. A is adjacent to this guy. So A is like, hey man, me and you, we make 180. But B is also adjacent to that guy. So B is like, hey man, me and you, we make 180. So he's like, whoa, if we make 180 and we make 180, I guess we're the same. So in this case, A equals B. They are congruent to each other. They're opposite each other, A fancy word is vertical angles, and that means they're congruent to each other. This is the congruent symbol. If you can't see that, I'll just do it bigger here. It starts from a similar symbol and an equal symbol. Congruent means both similar and equal measure. Let me get that out of the way. All right, so that's basically it. Now let's jog your memory on equations. So I have prepared for you, let's say, same diagram. You should probably draw it over yourself since you already did one with A and B. Let's say we got x and 2x plus 30. The directions say solve for x. What are you going to do? What's my relationship? Oh, okay, they're complementary. So x plus 2x plus 30 equals, here's a little clues. They should put the right angle there so you know it's a right angle. They should have that little box there. Sorry about that. Without that, you can't assume it's a right angle. Somewhere in the directions, they would either say these are perpendicular or it's a right angle. So let's see here, equals 90, because I have to add up to 90, complementary. Let me combine my like terms. Good thing I was paying attention in algebra. 3x plus 30 equals 90. Subtract 30. Can you see that? Yes, good. From both sides, 3x equals 60. Divide by the coefficient, and x equals, you don't need to see, you already know. 60 divided by 3 is 20. And then they might even push you further and say, well, if this is x, that means that's 20. And this is 2x, so that's 40 plus 30 is 70. And 20 degrees, 70 degrees, wowie, that adds up to 90. So it worked. Let me get that out of your way, because I know you got it. I'm going to need more room for this example. Let's say I got a straight line. Okay, so I know these are supplementary. Let me give you an example here. Let's go with x here, x plus 80 here. So again, you ask yourself your relationship. They look supplementary, so x plus 80 plus the other x has to add up to 180. Let me combine my like terms. 2x equals, equals 2x plus 80 equals 180. Now I'm going to do my additive inverse on both sides. 2x equals 100, right? That's an 80 in case I went too fast. Divide by the coefficient, and x equals 50. Again, I encourage you to play that same game. Once you get the 50 here, go back and say, well, I guess this guy's 50, and this guy's 50 plus 80, whatever that is. I think it's 130, right? 130 and 50, does that add up to 180? Yes! Okay, next. If you're looking at vertical angles, I'm going to erase this again so you can see. All right. Let's say this is 7x plus 16 and 3x plus 48. Okay, so let's say you're looking at this. 7x plus 16 and 3x plus 48. So you're saying, what's their relationship? Do I add them and get 90? Do I add them and get 180? Nope. I say that 7x plus 16 equals 3x plus 48. Now I can't combine like terms, so I'm going to subtract 3x. Ooh, there's going to be a video that explains how to get x, if it's on both sides, how to get it to one side of the equation. You're going to like that video, in case you're struggling in algebra. Goodbye. This is 4x plus 16. I hope that's a 48 there. Subtract 16 on both sides. Somebody get a calculator. What is that? 32. 4x equals 32. Divide by 4. Divide by 4. And x equals 8. So if it says solve for x, you're done. If they want you to double check your work, plug in the 8 and make sure that you get the same value here and here. Okay? Categorize your angles. I'm going to do another video which categorizes even more angles, because angles are everywhere. All right? We're not wasting your time. Angles are everywhere. Go outside right now. Bet you see an angle. See ya.